Hi everyone! This is the first of 3 lecture videos on this week's material. All of them should be viewed after you've already completed the other required readings and videos. In these slides, I would like to introduce study designs and measures of association. First, we'll talk about the difference between analytic and descriptive epidemiology, and then we'll discuss analytic study designs, and finally, measures of association. As you know from the definition of epidemiology, there are 2 basic functions or types. The first is descriptive epidemiology, which describes the distribution of health issues by person, place, and time. Here are some examples of descriptive research questions. In each question, there's just one health issue, and the question is about how this health issue is distributed by person, place, and time. The second type or function of epidemiology is analytic, with the purpose of investigating the determinants or potential causes of health and disease. The way that analytic studies find out if something is a determinant is by looking for associations between these potential determinants, also known as exposures and outcomes. Here are some examples of analytic research questions. Each question has 2 health issues. We call these issues variables. There's an exposure variable and an outcome variable. And now it's time for quiz 1, followed by quiz 2. We touched on analytical studies over the past 2 weeks. Now we're going to talk about them more in depth and learn about the different types of study designs that can be used to find out the answer to epidemiological research questions. So what exactly is a study design? This term refers to the method used to collect data. For example, epidemiologists could conduct an experiment where they administer some treatment to half of the people and a placebo to the other half. Alternatively, an observational study can be conducted where epidemiologists observe what happens to people in the real world. Most studies are observational because it isn't ethical to expose people to many of the potential determinants we want to know about, like smoking or stress or trans fats. Study designs covered in this class include cross-sectional, case control, cohort, and experimental. These designs are in order of how believable their results are. We will start this week with cross-sectional and case control study designs, which are quicker and cheaper than the other designs, so they're a good place to start when seeking the answer to a new research question, that is, something that hasn't been studied before. During the next 2 weeks, we'll learn how to identify study designs when reading a study description. As you can see here, we start by asking if the study is looking for an association between an exposure and outcome. If it's not, then it must be just describing a health issue by person, place, or time, in which case the study is a descriptive cross-sectional study. Next, we ask if the exposure was assigned. That is, did the study investigators give the exposure to the study participants? If so, the study is experimental. If not, if the investigators just observed or asked questions or took measurements but didn't actually assign participants to be exposed to something, the study is observational. Now it's time for quiz 3. We calculate different measures of frequency from the data of different study designs. If the study is cross-sectional, we calculate prevalence. If case control, odds. If cohort or experimental, incidence. Measures of association tell us about the relationship between an exposure and an outcome. Measures of association are calculated by comparing measures of frequency, either through subtraction in the case of difference measures or division in the case of ratio measures. Difference measures are called absolute measures because they tell us about the absolute difference in the number of cases between the exposed and unexposed groups. Ratio measures are called relative measures because they tell us how many times higher or lower the frequency is in one group compared to the other. Here's an example to help you understand absolute versus relative measures of association. You were running late for work and got stopped by a police officer because you were driving 60 miles per hour in a 30 mile per hour zone. How would the officer describe your offense in absolute terms? The officer might say, you were traveling 30 miles per hour over the speed limit. 60 minus 30 is 30, an absolute number of 30 miles per hour over the speed limit. If the officer were to describe your offense in relative terms, they might say you were traveling at twice the legal speed limit. So 60 divided by 30 is 2. So relative to the legal speed of 30, your speed was 2 times higher. Difference measures are interpreted as the absolute difference in number of cases between the exposed and unexposed groups. Difference measures give us the absolute number of cases that can be attributed to or prevented by an exposure. Here's a slide showing how to calculate the difference measures we'll cover in this class. prevalence difference, risk difference, and rate difference. We interpret the direction of difference measures by starting at the baseline, which is 0. If the exposed group and unexposed group both have the same number of cases and we subtract one from the other, we get 0. So 0 means there is no association between the exposure and outcome. When we subtract the prevalence, risk, or rate in the unexposed group from the exposed group and get a positive number, that is, a number above 0, the answer is interpreted as the number of cases attributable to the exposure. If the association is causal, then it is how many cases were caused by the exposure, or how many cases could be prevented if the exposure were removed. If the difference is a negative number, we interpret it as the number of cases prevented by the exposure. Note that we would always interpret difference measures per some multiple of 10, which just involves moving the decimal until you get a whole number of people. For example, if we have a risk difference of negative 0.03, we would move the decimal 2 places, and the interpretation would be, per every 100 people, the exposure prevented 3 cases. Now, on to interpreting ratio measures, which provide a relative comparison of the 2 study groups. Here is a summary of how to calculate the ratio measures we will cover in this class. The baseline for interpreting a ratio measure is 1, because if we divide the measure of frequency in one group by the measure of frequency in another group, and these numbers are the same, we get 1. So a ratio of 1 means no association between the exposure and outcome. If the ratio is greater than 1, the association is positive and can be interpreted as the number of times higher the frequency is in group A relative to group B. If the ratio is less than 1, it is negative, and we interpret it as the number of times lower the frequency is in one group relative to the other. Interpreting ratio measures is slightly less intuitive than difference measures, so I want to show you this number line with positive and negative associations. The farther away from the baseline of 1, the stronger the association. We can turn ratio measures into percentages, and you can find out how to do this from a resource on Canvas. You'll see it in this week's module. Here's a summary of the major points in this lecture. You can pause the video and read through them just to help cement these concepts in your mind. There are some quiz questions for you next as optional practice. Then there is a video on cross-sectional studies and another lecture video on case control studies. Please let me know if you have any questions at any point. Thanks, everyone.